First, there was a 1996 paper titled Shoreline Reconstructions for the Persian Gulf Since the Last Glacial Maximum, one of the early studies to consider paleo-shoreline reconstructions of the Persian Gulf relative to a gradual flooding. So the abstract reads as follows. Sea level change in the Persian Gulf since the time of last maximum glaciation at about 18,000 years before present is predicted to exhibit considerable spatial variability because of the response of the Earth to glacial unloading of the distant ice sheets and to the meltwater loading of the Gulf itself and the adjacent ocean. Models for these glacio-hydro-isostatic effects have been compared with observations of sea level change and paleo-shoreline reconstructions of the Gulf have been made. These reconstructions have implications for models of the evolution of the Euphrates-Tigris-Can delta, as well as for the movements of people and the timing of the early settlements in Lower Mesopotamia. That lower left image, you'll see it's dated 18,000 years ago. This is what the Persian Gulf looked like. 10,000 years ago, the Persian Gulf starts to fill up, and then 8,000 years ago, now we have, it's pretty much all of it starting to fill up really a lot. I'm going to show from a 2015 paper that there's evidence that it could have been a sudden flooding, as described in Genesis. That it didn't take thousands of years to fill, but it was a sudden flooding. Now, what I'm going to show based on the 1996 paper is, here's a video, counting down the years, and as you can see, I put the Garden of Eden over here, and notice that this region then is flooding. And then this is the present day. So again, if I play the video again, so the Garden of Eden will be around here. And then this entire region gets flooded. And then it stops around here. Now I'm going to make the point that this entire region gets flooded during Noah's flood, up until this region up here, which would be the Armenian Mountains. Some preliminary observations so far. Here's from a 2009 paper titled Pleistocene Climate Change in Arabia, Developing a Framework for Hominin Dispersal Over the Last 350,000 Years. Here we see a paleoclimatic record based on oxygen isotope stages. Most interesting in this chart is the direct correlation of arid conditions at stage 4. So stage 4 is this gray column over here, coinciding with the supervolcanic Toba eruption in Indonesia around that same time period that Jeffrey Rose was speaking about, 74,000 years ago, same time period as migration. The volcanic eruption will take place around here. Notice that you start to have a drop, and then closing in on what the animation was showing around 20,000, 50,000 years ago, you have a sudden increase. The point is that Toba's ash provide key stratigraphic markers that have been detected in Arabian sea sediments and could be the reason for human genetic bottleneck due to the onset of aridity, forcing humans into small population pockets in this region. Again, here's another 2009 paper titled, Did the Toba volcanic eruption of 74,000 years ago produce widespread glaciation? Not only do we have the sheets of ice on the mountaintops, but did this Toba volcanic eruption cause a further development of ice on the tops of these mountains? At the end of the abstract, we read the following. The volcanic winter following a supervolcanic eruption, the size of Toba today would have devastating consequences for humanity and global ecosystems. These simulations support the theory that the Toba eruption indeed may have contributed to a genetic bottleneck. Humans are then, in some respects, isolated in that one region for a brief period of time. Another 2009 paper titled The Red Sea, Coastal Landscapes and Hominin Dispersals. Now, this is in regards to the water level. On the y-axis here, you can see the water levels in hundreds of meters below present. 0 is present. Here is 70,000 years ago. Humans go into the Persian Gulf. Then there's a sudden rise, and then it peaks around the 13,000 year mark. Like, it starts to really shoot up very quickly. So the paper charts global sea level changes with the past 140,000 years. The dashed gray line is based on deep sea oceanic isotope records of planktonic and benthic fauna. The solid gray line shows the same curve corrected for temperature effects using dated and elevated marine terraces in New Guinea, and the dark solid line is based on isotope records from the Red Sea. What about the topography of the Arabian Peninsula? Here's a 2014 paper titled Cenozoic Epeirogeny of the Arabian Peninsula from Drainage Modeling. The paper was showcasing the uplift of the Hejaz Mountains and why these were generated upwards, the reason why this is being uplifted, and the Armenian Mountains and the Hejaz Mountains, but yet this remains relatively low level. Remember earlier I was talking about the Zanclean flood and how the floodwaters were going in a particular direction? Well, here's further evidence collaborated with the fact that this is low level, and so the waters flew down into this region. Basically, present-day aridity of the peninsula contrasts dramatically with elevated precipitation rates inferred for the Holocene and Pleistocene pluvial periods using oxygen records from stalagmites. they're saying that there's precipitation in this region compared to today per year was upwards to about 350 millimeters compared to the present day mean annual rainfall across Arabia is about 120 millimeters per year, varying from 40 to 80 millimeters per year in Rub al-Khali, about 150 millimeters per year in Yemen. And what I'm going to do is I'm going to say that the Holocene and Pleistocene period, well, specifically the Holocene with respect to Noah, is, as the Genesis text says, lots of rain, underground aquifer, lots of water underground, a localized low-lying region, topographically speaking. And so if Noah is in this vicinity, this is the region that gets flooded. Then came the 2015 paper titled Geomorphological and Hydrogeological Evidence for a Holocene Deluge in Arabia. Here we have the most accurate and latest research in regards to a sudden Persian Gulf oasis flooding 13,000 years ago. The abstract reads, Quaternary lakebed deposits have been recorded in different parts across Arabia, which are now drained by the eastward flowing drainage networks from Al Sarawat Mountains. The drainage networks are these black lines and some of these red lines. The ice caps of these mountains, water starts to drain down into this region. Simultaneously, the oceans are rising as well, and there's precipitation, and there's underground aquifers as well. So the analysis of digital elevation model, satellite images, and geological maps show that the lakebed deposits are mainly contained within a great arch depression occupying the trough between Al Sarawat Mountains in the west and the escarpment of Tuwaiq in the east and the Hadamawat Plateau in Yemen from the south to Wadi Sahan depression near the Syrian-Jordanian border in the north. The basins within this mega depression have been interconnected by tributary flows, which was consequent in the northward direction. The conspicuous ridge of Tuwaiq, which extends northward for about 800 kilometers and rises for approximately 200 meters above its western floor, has been breached by numerous subsequent deep incised canyons and funnel-shaped cuts carved at different elevations. The formation of several wadi canyons and funnel cuts along the entire extent of Tuwaiq clearly suggests that the breaching of this conspicuous escarpment was sudden and rapid, as the northern outlet of this mega lake was insufficient to discharge the water. The overflow arms have developed extensive alluvial fans on the Arabian coast. The fan of Wadi al-Batain, the Pishon River, covered approximately 60,000 kilometers squared in South Iraq, Kuwait, and northeastern parts of Saudi Arabia. The age dating of the quaternary deposits in different localities suggests the occurrence of this event between 13,000 and 8,500 years before present. So this happened between 13,000 and 8,500 years before present, at the end of the Holocene as well. These two images are from the paper itself. The top image showcases the general topographic relief and main hydrological features of drainage from the Sarawat Mountains and Gabal Tuwaiq escarpment. And so you notice that low topographic areas are displayed by the different shades of green, and the high areas are displayed in brown to gray. This bottom image. So it's a simulation of the extent of the Holocene flooding in this region, and it's where the Garden of Eden is. You can see the scale as well. So this scale here is 60 kilometers. You have 60 kilometers worth of water just flowing in this region over here. The quaternary wet climatic periods that prevailed during the early to middle Holocene were interrupted by three major phases of aridity, as interpreted from the paleosols, archaeological remains, erosional and blown sand surfaces intervening the paleolake and floodplain deposits. The basal unit of the early Holocene is remarkably composed of thick and homogeneous lacustrine deposits, which attain several meters in thickness at exposures. The geographical distribution of the early Holocene deposits in context of contemporaneous drainage basins show that the watershed divides and topographic barriers were breached in some locations by deeply incised canyons and in others by overflow channels. Approximately 5 deep incised have breached the Tuwaiq monocline, which is a prominent topographic barrier that dams the eastward flowing drainage of Al Sarawat Mountains. The northward gradient of the depression floor contained between Al Sarawat Mountains and Tuwaiq escarpment clearly indicates that the filling of this huge depression, approximately 1,200 kilometers in length, 200 meters high, and 50 kilometers width in average, is impossible using hydroclimatic estimates of all previous research. The dissection of Tuwaiq escarpment by several canyons in different areas suggests that the tributary flows have accumulated very rapidly into the depression trough, and its northward flow direction was not sufficient to discharge the deluge. Thus, this massive paleolake was breached in different areas. The breaching of Tuwaiq escarpment has also resulted in the development of extensive gravel terraces and mega alluvial fans. Therefore, it can be attested that the early Holocene period in Arabia has drastically reshaped the fluvial systems, groundwater, and, indeed, the early human civilization. Indeed, extensive research is needed. Cores of lake beds in Najd should be taken and examined for consistent and accurate age dating, and the archaeological investigation of sites buried under the flood deposits in Arabia must be revisited. Here's a rendering of what I think the flood looked like, using current satellite imagery of the Arabian Peninsula. The left image is an approximation of the landmass around Arabia prior to Noah's flood. The Pleistocene, Holocene, all of this would have been ice-capped and all that. So with ice still covering much of North America, Siberia, Europe, and the Arabian Mountains, global sea levels would have been lower, resulting in dry areas 150 meters below sea level. And the center image shows this is the flood, as seen in Genesis 7 to 8. If the Garden of Eden was situated, say, somewhere around here in the middle, and the Genesis text says that the ark rested on Ararat, I'm going to argue now that it's not Ararat, it's actually Mount Judy, or Kodu in Aramaic. And where this is located is just on the north point of where the waters stop in this flood picture. Because Ararat is still much further north. In order to reach Ararat, the elevations, you need water that will pretty much fill this entire region. And obviously that's impossible, naturalistically speaking. This region here is low-lying. Here are all the mountainous regions. And just at the base of the Armenian Mountains up here, the water is just high enough to reach this region here. And so therefore, I'm arguing that the ark would have floated and then landed up here. In regards to the size of the ark, the unfortunate thing is that the numbers in Genesis 5 and 6 are based on ancient Near Eastern scholars called Mesopotamian mathematics or base 60 number system. So for example, Utnapishtim, the Mesopotamian equivalent of Noah, his boat is 120 cubits per side. But notice that if you're working at base 60, the size will be 60 by 2. If you're talking about a volume, then it's 60 by 2 to the power of 3. The dimensions of Noah's Ark in the cubit measurement is shown to be 300, 30, and 50. The 300 is 60 by 5. The 30 is 60 divided by 2. 50 cubits is not specifically a base 60 number, but it seems to be some sort of symbolic number, like halfway to 100. When you combine these three figures, you get a resultant volume of 60 cubed by 2 and 60 squared by 5, which means this entire figure here is base 60. You technically can't reverse engineer into base 10. You can't put in the calculator and say convert 300 base 60 to base 10.
Furthermore, Noah's reed boat lands in the region of Mount Judy, or Urartu in Genesis 8 verse 4, close to this Edenic geography. The reason why it's a reed boat is because Noah used materials from a dismantled reed hut. Thus, the size of this boat would have been equivalent to a modern-day yacht, since the dimensions given in Genesis 6 should be understood via the ancient Near Eastern use of base 60, not our base 10. Furthermore, Genesis 6 verse 14 is usually translated, "Make yourself an ark out of cedar, constructing compartments in it, and cover it inside and out with tar." Recent scholarship has shown that these three Hebrew words for cedar, compartments, and tar all derive from Akkadian. Therefore, this is how the verse should read. "Make for yourself a vessel of stalks from a reed hut. With reeds you will make the vessel and tar it inside and out with bitumen." This is confirmed in the following Second Temple text. "Because of him, the earth was flooded. Wisdom again came to the rescue. She took a man who did what was right and steered him straight on a vessel made of cheap wood." This is the only reason in the end why humans can entrust their lives to cheap pieces of wood and can reach land safely by riding the breaking surf on a ship that is no more than a raft. Near the beginning, at a time when proud giants were being destroyed, the hope of the world escaped on just such a raft. This is the Wisdom of Solomon, chapter 10, verse 4, and chapter 14, verses 5 6.
Now, in Genesis, it does mention that the waters go up to 22.5 feet. This is simple trigonometric calculations where you take the radius of the Earth and you take h, in this case would be the head height in meters relative to the flood borders. If this was a global flood, why would the text go to the trouble in showing how high the waters were? Because it says that the waters reached a height of 22.5 feet. How would the observer know that the waters were 22.5 feet if below him there's already 8,000 meters of depth? So the fact that the text says that the waters reached a height of 22.5 feet means that they already had some form of measurement within their vicinity to know that the dry ground below us is 22.5 feet below us. So not only do I take into account the height of the flood waters, but I take into account Noah's height, which in this case is a conjecture. And then again, because of the arc dimensions that I gave in the prior slide, I conjectured that maybe the deck height would have been 8 feet. But the resulting calculation then, if you're not taking into account refraction, Noah's visual distance to the horizon would be roughly 8.42 kilometers. If you're talking about a flooding that's encompassing 750,000 kilometers squared of water, you're going to see your horizon is going to be full of water everywhere. It would look like the entire Earth is flooded, when really it's the local vicinity, that's the Persian Gulf region that's flooded. His visual distance is only maximum to about 8.42 kilometers. If you take into refraction, it does extend out further to 12.86 kilometers roughly, but here's where both charts are not taken into account. If you're going to have a heavy downpouring of rain, you're going to have underground aquifers, water coming out of the ground, and so on. The visibility is going to be harshly reduced. You're not even going to see 8 kilometers. You may be at most see 2 kilometers, even less.